Hi, good evening. Now let's look at the code for the three implementations which are there for the map. This is a single class which uses the hash map as the implementation. Use hash map is the class name and it has the main method. At the beginning, we have the declared type map. In place of key, we have a string. In place of value, we have a string. So this particular student grades, which is the reference name of the declared type map, is initialized to new hash map string comma string open close parenthesis. So I mean to say that every entry which you will be adding in this hash map will have string as a key and string as a value. So it is a string comma string map. So every call to the put method, see student grades is the reference name dot put means put this entry in the student's grade hash map. You have Zenith and then the grade is A. Then you have another entry Jitendra and then the grade is A plus. Then you have one more entry Amitabh and the grade is O. You have further entries which are there as Madhuri, then Adia and then Kishore and all. You'll find that one value is null. Okay, so it could be the case that Kishore is a student who has not appeared for one or the other exam. So his grades have not come into the entry. So it's null. Doesn't matter. So you have seen how to use put. Okay. So put is one method. You must have seen that in the method list in the PPT. Now you are going to look at one view of the student grade hash map, and that is a key set or set view. So when you say let me have the key sets segregated from the student grades map, then the method which you will be using is dot key set operated on the reference of hash map. You will get the key set as the output. If you are interested in getting the collections of values, then you will be using the dot values method on the reference of hash map. If you are interested in getting what is a value corresponding to a key, then you will be using the get method. If you are interested in printing that value, of course you will be printing it. If you are interested in replacing a particular value of a key, then you will be writing the key first, then the old value and then the new value, it gets replaced, and then the change you will be able to see over here. Okay, so let's run this and have the output. You have key sets, then you have values. Then if you are interested in getting what is the grade corresponding to Alia as the key, then it is B minus. Then if you are interested in getting the printing of the entire student grade hash map as such, then you will get first the key and then the value, again the key, then the value, again the key, then the value. You will find that the order of entry of the key value pair and the order of display of the key value pair is not matching. So this way you should get yourself convinced that hash map, key value pair, order of entry is not maintained and you can have a null for one or the other value. So this is about hash map. Now let's look at linked hash map. It's again a single class, linked hash map demo. You have a main method. Within the main method, map, which is a string by string map, is instantiated as student grade. See, this basic map is the same, even the values are the same. It is new linked hash map, string string. Now you are going to see the characteristic of linked hash map. In a sense, the order of entry is maintained. So that's what you are going to observe. These are the values are the same. I mean, like, these are the entries are the same as the earlier hash map implementation. We are going to look at the student grades, the display of all the entries, then segregated key set, then segregated values collection. Then you are going to update. You have Kishore with null value. You are going to replace that as A. Probably he has appeared for the exam and he has got the grade as A. Then you will be interested in getting what is the grade of Kishore as a key. So that has been obtained. Then that is printed, and then again the updated student grade map or key value pairs are printed. So let's run it. See, you have the order of entry maintained. This is the key set. These are the values in the form of a collection. Kishore got its value replaced from null to A. So it is the fresh value A which is appearing. And finally, the updated Kishore entry that you are going to see when you try to display the student grades again. So this is again the basic operation of the linked hash map. Characteristic: the insertion order of the entries is maintained. Okay. Let's switch to tree map. Okay, now again this is a single class tree map demo. It has a main method. It has an instance of tree map which has got key type as string, value type also as string. So map string string student grades equal to new tree map string string open close parenthesis semicolon means it is an empty tree map against the reference name student grades. Then you have certain entries added into the student grade as the tree map. Then you would like to display the student grades. See, the display is on the basis of the lexicographic order because the keys are string. So accordingly you should expect the entries displayed. Then you have the separation of key set, then you have the separation of values, then you have the student grade for Kishore identified separately, and then you have printing of student grades again. So let's see. See, you have the first entry as Ilya, then Amitabh, then Jitendra, then Kishore, then Madhuri, and then Zina. So this is the key set. This is the value collection. Then the grade corresponding to Kishore is O, and then finally this is the printing of the student grade again. Of course, we have not had any replace or something like that because replace is commented, but still the same structure of the program I've used for all the three implementations to be shown. So that is repeated, but you can get yourself convinced that for tree map as the implementation of map, you have sorted entries displayed as per the keys and not as per the values. Okay. So this is all for the implementations of map, hash map, linked hash map, and tree map. Now, as an exercise, I would like to give you something such that you will be in a position to verify whether the tree map gets sorted as per the natural order of numerics, which is an ascending order or not. Okay, yeah, that's it. Thank you.